Alright, welcome to the Unit 2 review. As you're working through the review, pause the video, work out the solution, and then check your answer. Alright, so as we look at the first problem, we're just solving the equation. A lot of different ways you could start this, but I would distribute the -3 in first. And so we get a -3 times 2 gives us a -6, and a -3 times 1 gives us a -3. So here you could add the 6 over, but to get rid of this fraction, we're going to multiply the whole thing by 3. And as we do that, it's basically distributing the 3 to each and every term. And so here the 3's cancel, and I get 1x. 3 times 6 is 18. 3 times -3 is -9. 3 times -6 gives me -18, and 3 times 1 gives me 3. So now I have like terms that I can combine. So 1 minus 18 gives me -17. So now we just want to solve for x. So we add the 18x to both sides. So -17 plus 18 gives us 1x. Now we move the 9 to the other side. And that gives us x equals 12. And so now you'd want to take that 12 and plug it back in. Alright, so write the equation in slope-intercept form. So remember, the 8 is my input, the 3 is my output. So that means you can write that as an ordered pair, 8, 3. Same thing here, 20, 0. So now we can use those 2 points to find the slope. So our slope formula is y2 minus y1 over x2 minus x1. So this is my x1, y1, x2, y2. So x1, y1, x2, y2. And so that gives us -3 over 12, which reduces to -1/4. And now we're going to go to our point slope formula. Y minus y1 equals m times x minus x1. And so I'm just going to use the ones already labeled x1, y1. So the 3 goes where the y1 is. My -1/4 is going to go for where my slope is. And my x1 is 8. So now I want to distribute this in. So -1/4 times x and a -1/4 times 8. So watch the sign. A negative times a negative will give us a positive. And now we add 3 to both sides, and we get y equals -1/4 x plus 5. We'll talk about the parent functions on Kahoot. Alright, so now is the given point a solution to the system? So all we're going to do is we're going to take the x value and the y value and substitute it in. So wherever you see an x, put a 5. Wherever you see a y, put a 1. So we replace them, and then we do the math. So -10 minus 7, that does equal -17, so that does work. Now we got to try the second one. If it didn't work here, there's no point to try the second one. But since it worked, we'll try the second equation. So we'll put the 5 where the x is and the 1 where the y is. Do the math, and we get 1 is not equal to 20, so this point is not a solution. So 5, 1 is not a solution to both equations. Alright, so we're going to graph this. We want to see where the 2 lines cross. So y equals 1. Is it a Hoy or a Vux? So it's a Hoy. So we're going to draw a horizontal line at 1. And now we'll start with our y-intercept of 4 and our slope of -1/2. So down 1 over 2. Keep going until the 2 lines cross. And so we think our answer is going to be 6 comma 1. Now let's check it. Now for the first equation, I only have a y value. So the only thing you can plug in is the 1. You have to ignore the x because there's nowhere to put the x. So 1 does equal 1. So that works. Let's try the second equation. So now I have a place for the y, I have a place for the x. A negative times a positive is going to give us a negative, and half of 6 is 3. And so we get 1 equals 1. And so that guarantees we got the answer right. Alright, same thing. Now we have two equations that we can graph. Alright, so we have negative 4. And we're going to go up 2 over 1. And it's just a good idea to carry it out a little bit. And our second one has a positive 4 as a y-intercept. So now we go down 2 over 3. The line's crossed. So I think the answer is going to be here at 3 comma 2. And so we should check it into both equations. Put the 3 where the x is, and the 2 where the y is, and do the math. So we get 6 minus 4. So 2 equals 2 works. Now over here, the 3's here are going to cancel. I'm going to get negative 2 plus 4. So 2 equals 2 again. So it looks good. Alright, so now when we solve the inequalities, you're going to have to remember that we're going to do some shading and a solid line or dashed line. So that x is going to be a Hoyer of x. Okay, so we're going to have a vertical line at negative 3. And do we draw a solid line or a dashed line? And so we're looking at this symbol. Since there's no line underneath it, we draw a dashed line. And then now do we shade to the right or to the left? Since it says x is greater than negative 3, all the numbers that are greater than negative 3 are on the right. So we would be shading to the right. Here we start with our next equation, and so it's a negative 4. Now we go up 1 over 3. Just carry it out a little bit. And then now is it going to be a solid line or dashed line? Again, we're looking at this symbol, and since it has a line underneath it, the equal to is going to be a solid line. And then now we ask, are we going to shade above or below? So greater than is going to be above the line. So we have arrows going this way. And we're looking for the overlap. So the overlap would be here. So ideally, that's the only thing you really want to have shaded. And also notice that I'm not shading on top of my lines because if I shade on top of this line, it might appear to be solid. So I really want that to stand out. So let's see, where do the two lines cross? So here at negative 3, negative 5. Looks like that's the point where those two lines cross. Anything over here would not be a solution. So if I ask you, give me a point that's not a solution, you could say this point here, negative 5, 0, is not a solution. If I said give me a solution, any point in the shaded region, 0, 0 would be a solution. We talk about some types of solutions on Kahoot. Alright, so let's solve some by substitution. So when they're already set up this way with the y equals and the y equals, the easiest thing is just to put them equal to each other. So it's basically substituting in this value where the y goes. And now we solve for x, so we minus 2 to both sides. Add 6. Divide by 2. And we get x equals 5. So now let's take that 5 and plug it into one of the original equations. Doesn't matter which one. So replace the x with a 5. And so I think the answer is going to be 5, 14. So let's verify it. Since we use the top one to get our answer, we'll use the bottom one to check our answer. And 2 times 5 is 10. And so 14 equals 14. So we got that problem right. So now we're going to try solving using elimination. And when we eliminate, we need to have opposites. So I have a negative here and a positive here. So I'm probably going to get rid of my x's. So I want this to become a positive 4. So what would I multiply the top equation by to make this x a positive 4? So I'm going to multiply by 2. And so that gives, so I'm basically distributing 2 times 2, 2 times 3, 2 times 12. And I didn't need to change the bottom, so I just rewrite it. So now I can add the equations together and then solve for whatever variable is left. So we're going to solve for y. And we get y equals 2. So let's take that and plug it into one of the equations. I'm going to plug it into the top equation. So put the 2 where the y is. And then solve for x. Minus 6 to both sides. Divide by 2. And we get x equals 3. So I think the answer is 3 comma 2. Since I used the top equation to get my answer, I'll use the bottom one to check it. So take the 3, put it where the x is, take the 2, put it where the y is, and do the math. So we get negative 12 plus 10 equals negative 2, and that works. Negative 2 equals negative 2. So we know we got it right. Now we can go to the next one. Alright, we want to make opposites. I don't have opposite signs at all, and so I'm going to work with the x's because they're smaller numbers. And the easiest thing to do is you can just multiply the top by 4 and the bottom by negative 3. We have to multiply by one negative to get opposites. So I multiply the top by 4 and the bottom by a negative 3. So it's basically we're distributing. 4 times 3 gives us 12, negative 16, positive 24 on the bottom. Negative 12, positive 15, negative 21. Now we can add the equations together because we have our opposites. And we get negative 1y equals 3. Divide both sides by negative 1. So we get y equals negative 3. Take that and plug it back into one of the originals. Don't plug it into the one you multiplied by, because if you made a mistake here, you won't catch it. If you plug it in here, you'll be good to go. Alright, so that's going to give us positive 12. Now move the 12 to the other side. Divide by 3. And so I think the answer is a negative 2, a negative 3. So let's take that into our second equation and see if it works. So 7 does equal 7, so that means we got it right. Alright, let's take a look at solving a system of 3 equations. Alright, so as we look at the system with 3 variables, we want to pick the easy one to get rid of. So the question is the x, the y, or the z. You really could get rid of the y or the z. I kind of like the y better because it's a nice positive one here, although the z is fine with this being a negative. I like that these are negative 4, negative 4. So it's going to be the same amount of work either way. So I am going to get rid of the y. So I'm going to work with equations 1 and 2 first. So I'm going to do equation 1 plus equation 2. So to get rid of the y's, I need to have this here be a negative 4. So I'm going to multiply that second equation by negative 4. So I'm not doing anything to the first equation, so I'm just going to rewrite it. So a 3x plus 4y minus 4z equals negative 11. And now here, I'm going to multiply everything on that second equation by negative 4. So that gives me negative 16x, negative 4y, plus 16z, and negative 4. So I have my opposites, so I can add them up. So the y's are going to go away, and so I get negative 13x plus 12z equals negative 15. And so we'll call that equation 4. Now, we worked with equations 1 and 2. Now let's work with equations 2 and 3. So working with equation 2, again, we're getting rid of the y's, so I want this now here to be a negative 3. So I want to multiply that whole equation by negative 3. So we get negative 12x minus 3y plus 12z equals negative 3. And then the third equation I didn't do anything to, so I can just rewrite it. X plus 3y minus z equals negative 8. Now we can add them up. The y's go away. I get negative 11x plus 12z, not 12, 11z equals negative 11. And this will be our equation 5. So I'm just going to rewrite them so I can look at them and decide what I'm going to get rid of. Alright, here I'm going to get rid of the x. So I'm going to get rid of the x. So I'm just going to multiply the top by 11, the bottom by negative 13. Not nice numbers, but you gotta do what you gotta do. So 11 times negative 13 gives us negative 143x. 11 times 12, positive 132 z. And 11 times negative 15 is negative 165. Now multiply the bottom by negative 13. The one good thing about this is that they're all going to be the same number, so positive 143x minus 143z positive 143. So I have the x's that are opposite, so they're going to go away. So now look at your sign. Do you have more negatives or more positives? And we have more negatives, so we know our answer is going to be negative. Now just subtract 143 minus 132. Look at your signs. You have more negatives, so you know the answer is going to be negative. Now subtract 165 minus 143. That gives us 22. Divide both sides by negative 11. And we get z equals negative 2. Not negative 2, positive 2. Alright, so now we're going to take that 2 and plug it into one of our equations, 4 or 5. I think I will plug it into 5 here. So it's going to be negative 11x plus 11 times 2 equals negative 11. minus a 22 to both sides. And so we get negative 11x equals negative 33. Divide by negative 11, and we get x equals positive 3. So now I know my x value, I know my z value. So now I just got to find my y value. So I'm going to plug it into one of the easy equations. It'll give you the same answer no matter which one you use, but I think I'm going to work with equation 3. So x plus 3y minus z equals negative 8. So plug the x in, plug the z in. So 3 minus 2 is going to give us 1. Minus 1 to both sides. Divide by 3, and we get y equals negative 3. So my answer here is 3, negative 3, positive 2. I do want to check that into at least one of the other equations. So let's check it here. 3 times 3 gives us 9. The y is negative 3, so that'd be minus 12. And the 2 would give us negative 8. And so if you combine these, you get negative 20. So 9 minus 20 does equal negative 11. So looks like that's a good answer. All right, so we have the word problem. As you read through it, remember we want to put our like things together. And so we see that when we have 12 vans and 5 buses, that gives us 384 students. So these are our like things. The other one is 3 vans with 4 buses, gives us 261. And so now we have our system that we can solve. The easier variable to work with is going to be the v, because then I only have to multiply one of the equations. So I'm going to multiply the bottom by negative 4. So now I have my opposites. So my v's are going to go away. I get negative 11b equals negative 660. Divided by negative 11. So we get b equals 60. Now I'm going to plug it in. The bottom equation looks easier to work with. So 4 times 60 gives us 240. Minus 240. Divided by 3. So it looks like it's going to be 7 vans and 60 buses. Just to make sure, take your answers and plug it into the other one. And 84 plus 300 does equal 384, so that looks like that's a good answer. 7 vans, 60 buses. Seven people per van and 60 people per buses. Got it. Alright, so now we're going to graph a system. We've kind of already done this, but now we're going to have the absolute value. And so we look at the x. And so that's going to be a Hoyer or Bucks. And so we draw our vertical line at negative 5. It's a dashed line. It's a dashed line because there's no line underneath. And then do we shade to the right or to the left? Since it's greater than, our greater than numbers of negative 5 will be to the right. So we shade to the right. And so now we're going to graph our absolute value. So we have that negative 2. But remember, whenever x and the number are touching, x is a liar. So we're actually going to graph that at positive 2. And it's going to be a solid line because it has a line underneath. And then we shade above or below. Greater than would be above. And so we're looking for the overlap. And so that's what we'd want to shade. All right, describe the transformation with words and write the absolute value function. So if I give you those 5 dots and ask you what absolute value goes through that, start with the parent function and just describe what you'd have to do. What would I have to do to that parent function to move it to the red dots? Well, the parent function has to be moved 2 units to the left. So if I move the parent function 2 units to the left, it's right on top of the red dots. So remember that whenever it touches the x, it's opposite what you think. X is a liar, so this would actually have to be x plus 2. Alright, now we want to write the absolute value function for the blue dots. Okay, so how would I get the parent function down to the blue? Let's go down 4. And so it's not on the x, so we can trust it. And so it would be absolute value of x minus 4. And the last one here, we're going to take this one in steps. So notice that the parent function starts going up, whereas my orange dots are going down. So it gets reflected across the x to start with. And so the negative goes in front of the absolute value bars. So let's move it now to the right, 7 units to the right. When it's along the x, remember x is a liar. So I'm going to say x minus 7. And now I need to move the graph up 4 units. And so we can trust that, and so that would be on the outside.